Welcome back to the channel. Today we're discussing thruster motors. These powerful devices, typically housed in the bow and sometimes the stern of a vessel, are the ultimate maneuverability tools, turning massive ships into nimble dancers in crowded ports and tight channels. Think of them as the ship's powerful sideways paddles. Thrusters are essential for dynamic positioning, docking, and navigating in slow-speed restricted waters where the main rudder is ineffective. A ship's conventional rudder only works well when the ship is moving forward at a decent speed. But in a port, you need precise lateral control, and that's exactly what the thruster motor provides. The heart of the system is the thruster motor itself. These are typically robust, high-torque AC electric motors, often of the induction type, designed to deliver high-power output for short bursts of intense maneuvering. The motor drives a propeller housed in a transverse tunnel that runs from one side of the hull to the other. When the motor turns, it pushes a high volume of water out of one side of the tunnel, generating a powerful sideways thrust on the ship's hull. The motor can also reverse its direction, instantly creating thrust to the opposite side. The power to run these motors is immense and comes directly from the ship's main generator sets. Since a thruster motor can represent one of the largest single electrical loads on the ship, their operation is carefully managed by the Power Management System, or PMS. The PMS ensures that sufficient generator capacity is online and synchronized before the engineer or pilot can engage the thrusters. This prevents an overload, which could cause a sudden blackout of the ship. There are several types of thruster configurations. The most common is the tunnel thruster we just described, fitted permanently into a tunnel near the bow. Some larger or specialized vessels, like ferries or cruise ships, also feature a stern thruster to provide precise control over the aft end. A more advanced design is the azimuth thruster or propeller pod, which isn't just for maneuvering, it can also provide main propulsion. These units are mounted beneath the hull and can rotate 360 degrees, offering thrust in any direction. However, the motors we're focusing on are the dedicated lateral thrusters used for fine control. Operating the thrusters is usually done from the bridge using a simple joystick control. The officer or pilot moves the joystick left or right, and the control system instantly commands the motor to start, reverse, or modulate its speed via a variable frequency drive, VFD. The VFD allows for smooth, incremental control of the motor speed, which translates directly to precise thrust control, avoiding sudden jolts of power and making the ship easier to handle. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.